In this video, we're going to take a look at MathCounts Warm-Up 1 from the 17-18 problem set. Number 31. What is the value of 5 minus 5 times 5 plus 5 divided by 5? Well, this is just an order of operations question, straightforward. So we're going to do all the multiplication and division first from left to right. That gets us 5 minus 25 plus 1. Then we'll do all the addition and subtraction left to right. 5 minus 25 is negative 20. And then we're adding 1, so we're going back up 1, and we end up at negative 19. Number 32. How many diagonals are in a convex heptagon? Well, the formula for the number of diagonals in a shape is n times n minus 3 divided by 2, where n is the number of sides in the shape. So in a heptagon, we have 7 sides. So we're just going to plug 7 into n, and that gets us 7 times 4 divided by 2, which is 28 divided by 2, which is 14. So our answer is 14 diagonals. Number 33. What is the first year after 2018 that is a palindrome? So palindrome means it reads the same forwards as backwards. So it can't be 2, 0 because the next digit would have to be a 0. So it's got to be a 2, 1 and then a 1, 2. Next year is 21, 12. Number 34. A standard 52-card deck of playing cards includes 4 aces. What is the probability that 2 cards selected randomly without replacement will both be aces? So this without replacement is key. Express your answer as a common fraction. Well, the probability that that first card is an ace is 4 out of 52. And now there are only 3 aces left in the deck, and there's only 51 total cards. So 4 over 52 times 3 over 51. And to simplify that, we can simplify 4 over 52 to 1/13. That makes sense because there's 13 cards in each suit, and there's 1 ace in each suit. And then 3 over 51, I know I can simplify this because 5 plus 1 is 6, and 6 is a multiple of 3. Therefore, 51 is also a multiple of 3. And that is 3 times 17. So the probability is 1 over 13 times 1 over 17, which is going to be 1 out of whatever 13 times 17 is, which is 221. So this is our final answer for this one. 1 over 221. Number 5. What is the value of the square root of 2 times 3 times 4 times 5 times 6 times 7 times 10? Express your answer in simplest radical form. So simplest radical form means if there's any perfect squares in here, we're going to pull them out and put them outside the square root symbol. So in other words, if we ever see something like this, let's say we had 2 times 2 times 3. Well, the square root of 2 times 2 is 2. 2 times 2 is 4. The square root of 4 is 2. So we would take that 2, bring it outside, and we leave the 3 inside. So this would be simplest radical form for square root of 2 times 2 times 3. So for this one up here, let's break it. Let's break all of these numbers down into their prime factorization. So 2 times 3, now times 4, we can break 4 into 2 times 2, times 5, times 6, which is 2 times 3, times 7, and then 10 is 2 times 5. And now we're going to pull out the perfect squares. So we have right here, we have 2 times 2. So that's a 2 that we're going to pull out. And then we have another 2 times 2. So that's another 2 that we can pull out. Then we have a 3 times 3. We can pull it out and make it a 3. And we have a 5 times 5, which is 25. Square root of 25 is 5. So that goes outside. And what do we have left inside? Just 7 times 2, which is 14. And then outside, we would do 4 times 15, which is 60. So our final answer is 60 root 14. Number 36. The temperature dropped from 13 Fahrenheit to 5 degrees to negative 5 degrees Fahrenheit. How many degrees Fahrenheit is the absolute value of the change in temperature? Absolute value means they don't care if it's positive or negative, just how much distance did it travel? And that would be 18 degrees, because it started at positive 13. And then to get down to 0, it went down 13 degrees, right? And then it went down another 5 degrees to get to negative 5. So the total distance here from 13 to negative 5 is 18. It's going down 18, so negative 18, but it just wants the absolute value of the change. So that's just positive 18. Number 37. What is the value of blah, blah, blah? Express your answer as a common fraction. Well, again, we're going to follow order of operations. So 1 times 2 is 2. Then over here we have 3 divided by 6, which is 3 over 6, or 1/2. 1/2 times 5 is 5/2, 5 over 2, minus 4. And now we're going to go left to right. 2 plus 5/2 is 2 plus 2.5, which is 4.5. And then we're going to subtract away 4 from 4.5, and we're left with 1/2. All right, number 38. If x r y is defined as x squared minus y squared, what is the value of 3r parentheses 2r1? So this is a function problem, and the notation can look tricky, but it's actually really straightforward because we just are going to plug these values into this function. So here's the function. It says xry is defined as x squared minus y squared, which means take what's to the left of the r, plug it into the x slot, take what's to the right of r, and plug it into the y slot. So first we're going to focus on this 2r1 right here. So 2r1, we're going to plug that into the function, and we do 2 squared, because 2 is to the left of r, so it's in the x slot. 2 squared, that's 4. And then y is 1, so minus 1 squared, which is 1, and that equals 3. So this right here, 2r1 equals 3. So I'm going to replace it with 3, and now we have to evaluate the function one more time. We have 3r3. So we have 3 in both slots. And so when we plug those in, we're going to get 3 squared minus 3 squared, which is 9 minus 9, which is 0. That's our final answer. All right, number 39. If the digits 7, 8, 2, 3, and 0 are used, each exactly once, to form a 3-digit positive integer and a 2-digit positive integer that differ by exactly 288, so they're 288 apart, what is the sum of the 3-digit integer and 2-digit integer? So this is one where you're going to really just want to play around with it. So I know I have a 3-digit integer subtracting a 2-digit, and I end up with 288. And I have to use the digits 7, 8, 2, 3, and 0. Well, if you play around with it, you can figure out that this number has to be 370, and this number would be 82. And it says, what is the sum of these two integers? So we're going to add them up. And that gets us 452. Finally, number 40. This is my favorite one. In rectangle ABCD, point P lies on side BC. So let's pause there. What you always want to do in these geometry questions is make a good diagram. That's going to be half the battle. So let me try to draw a big, already off to an inauspicious start with that first crooked line, but that's okay. I'm going to draw a big rectangle ABCD. Point P lies on side BC, and point Q lies in the interior of the rectangle, so that triangle APQ is equilateral. So this might not be perfectly to scale, but that's okay. So point Q lies here, so that this triangle is equilateral. It looks more isosceles than equilateral, but that's okay. Now, since it's equilateral, I know that all these three angles are 60. So I'm going to mark that. Anytime you know something about a diagram, draw it in. Okay, 60, 60, 60. If the measure of angle PAB, see I messed up because I put Q here for this point. This point should, this point up here, sorry, should have been P. If the measure of angle PAB is 17 degrees, it's right here, 17. What is the measure of angle QPC? QPC, so we want to know this one over here. Well, if I focus on this triangle right here, triangle ABP, I can find this top right angle in the triangle because it's a rectangle, so this angle is 90 degrees. 90 plus 17 is 107. The three angles in a triangle have to add to 180. So this triangle right here, this angle right here is going to be 73. And now, these three angles right here that I'll draw a yellow arc over, those three angles form a semicircle, right? So they're supplementary. Another way to think of it is they lie together along a straight line and share a common vertex, so they're supplementary. The way I like to think about it is if you can draw a half dome over any number of angles and they're all sharing a common vertex, it's like they're all sleeping under that tent. So they have to all add to 180 degrees. So then the green angle, you would do add 73 and 60, you get 133. And you can subtract that from 180. And that gets you 47 degrees.